Okay, welcome back. This is the last of the power supplies out of the IBM server. This is a more conventional design and construction as what we're used to. This one, I suspect, supplies the I/O, the input-outputs, interface sections, disk drive sections, or whatever peripherals that the server needs to communicate with the outside world. This one, I think there was 4 of these in my server, and I think this is the last one I have to break down. It has on the outside 2 power inputs and your power lights, faults, power on, power in, power fault, power out, power drawer fault. It's steel construction, it's all steel, it's pretty heavy. On the back side, it plugs into this motherboards. It's got all your power connections, some data pins and more power connections, and I think it has provision for a fan, 3-phase fan. Let's have a look at the rating plate for this. It has a unique locking system for locking this into the rack, and for removing it you have to unscrew this so that it pulls it in. When you do these up, it pulls it into the rack and locks it, the connector at the back. Alright, so let's have a look at the nameplate, or the badge here, and see what it says. So in this power supply, it takes in 350 volts just like the others, 6.6 amps, and it has multiple outputs. A 2.5 volt supply at 40 amps, a 3.3 volt supply at 150 amps, a 5 volt at 110 amps, 12 volts and 12 volts at 40 and 2 amps. And then it has, like I said, the fan controller, 235 volts, 0.7 amps, 3-phase, 2 of them, so you can run 2 fans, I guess. It's got water damage on it, some rust staining. So let's have a look here at the ends. We've got cross ventilation from the ends. There's nothing on the side or the bottom. There is some ventilation on the top, and there's ventilation on the end too, so a little bit better ventilation than the other ones. Let's pull the lid off and see what we got inside. Alright, screws are out. Let's have a look. So we got a lot of stuff going on here. This is quite the unit. This board here is all control. It has a Cyrix processor, or is it Intel? I'm not sure. But there is flash ROM here. It's an 29F400. So what is that? 4 gigabytes or 4 megabytes or something? I'm not sure. Let's see here. What is this? This is a fan controller, fan output, and the cable goes across to here. And this, I believe, is the fan, the board that generates the 3-phase signal for the fan, or 3-phase power for the fan. Let's get it correct. Pull this one out, and that is connected to the fan output. Yes, that is a H-bridge 3-phase. It's got a Texas Instruments TMS 320 LF 2406. I think that's some kind of controller. A little bit of power conditioning and filtering here on the input where the power comes in, and then it just goes straight to the output here. There's 3 transistors, 3 and 3, and then 3 and 3. And I believe those are insulated gate bipolar transistors. I'm not sure, but it's pretty conventional with the other boards of for the fan controller that I've been looking at. It just takes the 350 volts DC and converts it into a 3-phase signal for the fans. Yep. Oh, I got silicone blobs on the... But I'm assuming these are variable speed, controlled by the controller and everything else. Let's put that aside. This part here, if I can get it around this camera, this part here looks like it's some kind of a controller. It's got flash ROM and a firmware installed, so it must be doing something important. See if we can get this off. Okay. So all it has is interconnects on this side, and it connects with these 5 little boards here. And these come out too. Some glue logic on there. UCC 3895 DW. Doesn't seem to be any kind of power handling on these little boards. This is more like control. Maybe these are interfaces between the... you know what? This might be opto isolation. I don't see any opto isolation on this. Any opto isolation on this thing either? I don't think so. Anyways, here's a good look at the board. Like I said, there's a couple of ROM chips here, and they're flashed with some kind of a firmware. Got stickers on them. 3 Max controllers here. These are Max 306 EQI Max, and I think that's what's doing the business for these. Seems to be 3 independent circuits here. Not much else going on. Okay, so let's have a look at this. We got 5 of these cards, and I think they're all identical. Yep. Okay, now we have some supplies here. We have a switching power supply here. That's all a module. We'll take that out in a second, but I believe this is our 2.5 and 3.3 volts. There's 2 outputs here, and they're very high current. It looks like they have gold-plated. The board is gold-plated, and there's lots of vias around here, and there's a couple of big M6 bolts holding it together. We'll look at that in a minute, but let's look at the rest of this. It looks like we might have a couple of different power supplies here. These might be the 12 volts, and typically you can look at the filter capacitors and see what kind of voltage range we're dealing with. For example, these ones are 6.3 volts and these are 6.3 volts, so these two are a low voltage supply. This one here is 25 volts, 25 volts. So these are probably our 12 volt supplies. There's inductors embedded in the board here. I don't know what they're doing. Those are power no, those are inductors. They're marked L as opposed to a transformer that's marked T. So I got power coming in on 2 independent feeds for redundancy. And again, I think we have a diode that blocks power backfeeding into one to the other. And we have some signal conditioning or power conditioning here. There's some common mode chokes and some capacitors. And this is on the input side here. And this kind of cleans up the voltage coming in. Here's a fuse, and that is a 600 volt 2 amp. Is that the only fuse in this whole thing? This is a 6 draw 6 amps, so I don't understand why they have a 2 amp fuse. So we got 2 supplies here. I'm assuming 2 supplies here, and I think there's another small supply. What was our voltages again? Let's remove this from the chassis and we'll get a better look at it. Alright, I got the majority of the screws out, but it's still holding here. I think this module has to come out first. Seems to be the big stumbling block here. Yeah, those are M5, not M6, sorry. A little insulator, and then it's tied straight to the board. And I think this is socketed in. It pulls out these connectors. Come on. Tight. Oh my goodness. Okay. Okay, so this module comes out. We'll look at that in a bit. And here's our hidden screws. Okay, I think we should be free now. Yes. Take this out. Alright, so I think I know what's going on here. We have a number of different supplies in one box here. If you look here, we got level 3, level 4, level 5, level 6, level 7. And I assume level 1 and 2, where that module was the module that I took out, it has 2 outputs on it. This one and this one. And these are both high current, low voltage, according to these caps. This bank of capacitors here. So that's the level 1 and 2, and then level 3, 4, 5, 6. And if I look here between the boards, between the components, I can see it's marked. Where did I see that? Level 5 is written here, level 6 is here, and I don't see 7 or 3 or 4. But this might be a switching power supply right here, a little tiny transformer. This might be a 2 amp supply, that 12 volts. These ones are obviously higher current, and so on. So there's probably several supplies here. Here's 2 outputs here, and they're fairly high current. They have a lot of width on their trace, and there are a lot of vias poking through the board. And there's an inductor here, an inductor here, and some high current resistors here. So I think there's some, this is all output and output filtering for one of these 2 supplies. Yeah, there's one here, one here. On the back side, it's pretty conventional. We got a lot of surface mount diodes everywhere. They're all over. And we have 4 of these chips. What are these? These are PCA 9544AD. I don't know what they are. Pretty typical. So the way it works is we have our controller, and this is the brains of the operation. through the board. It's connected, and you know, input output data pins here flows through. I don't see any isolation though. That's the only thing. Maybe I'm missing it. There is isolation on this board. Where did I see it? Some right here. This opto isolators. And that might be tying back to here. So anyways, you got the controller. And then after the controller, we got these four, let's call them the slave boards. I guess they handle each tier or each level, each one. And then from here, it goes to and controls these power supplies. And everything's monitored and alarmed, just like normal. So let's have a look at the other part. This part here is kind of a self-contained module. It has a heat sink. It's got some nice large inductors on the back. It's got semiconductors here, rectifier diodes here underneath. It's got filtering capacity. It's got some tantalums. Let's open this one up. Let's take off some screws and see what we can do here. And these are some band clamps that holds the inductors down. No, they don't want to come apart yet. We'll get to that. And they're split inductors. We have a brass and you notice they're not fully clamped to each other. There's a piece of insulating plastic to keep these separated. I wonder what the reasoning is behind that. This could control the inductance, I guess. I don't know. Let's see here. Let me get this out. It just clamps the board down. Let me take out all these screws and then I'll come back. Check out these plastic screws they use, insulating screws. They're transparent. I don't see these very often. They use them around, you know, heat sinks and stuff where you have to insulate something. There's a plastic screw. That's kind of cool, eh? There's another one. Holds the board down. I don't know why they have a... Maybe there's a lot of induced magnetic fields here. Maybe they were trying to keep down the losses in the heating by using plastic screws. But anyways, here's... This thing's ready to come apart, I believe. What's holding it? Here's the heatsink. It's got a little riser there, and it's a nice heatsink. It's here is the business side of things. We've got a sill pad, covers all these MOSFETs. Another sill pad that covers all of these rectifiers. These are Schottky rectifiers. These are all MOSFETs. And there's a couple, 4 transformers, 6 transformers. There's another 2 more. Oh, sorry, 4 more. So there's 8 total. So all your power and control signals are coming in here. Your drive signals, control signals, any feedback is coming through this connector. And these 8 MOSFETs are doing the switching for these 2 channels. Let's get rid of that. These are two inductors. They're filter inductors, they're not transformers. And all of the conductors are embedded in this multi-layer board. And we have two transformers here, it looks like. Let's pop one of these off. They're glued, so it's going to break, of course. Okay, take this one off as well. This cleaned up. Take this out. You gotta watch, this stuff is sharp like glass. And these are our transformers. Everything's embedded in the board. There's multiple layers, and you can see that here. I don't know what it looks like. It looks like there's, if I had a magnifying glass, I might be able to count them. I don't know. Yeah, there's too many layers to count to know for sure. I'd have to cut this open. But anyways, we have our MOSFETs doing our switching. Got a really low ESR capacitor here, just for the power conditioning. Got 4 MOSFETs for each channel. Looks like we have our transformer here, and then after the transformer, it's low voltage, high current, goes to our rectifier diodes, or bank of rectifiers. So this is how the magnetics work for that one inductor. It's there's a plastic spacer that they put on here, and the center of it is touching, which makes a magnetic bond. But then on the outside you have probably, I don't know, is that 0.6, 0.5 millimeters gap? I'm not sure exactly why they would do that. But then I'm not a magnetics engineer, and I don't know much about inductors in high frequency switching power supplies, so it's kind of interesting. And from there, the current's carried through these big bus bars to a capacitor bank. There is capacitors on this side, and there is no capacitors on the other side. But this is preliminary filtering. This isn't. This doesn't do all the business, because we had on the board, we had a bank of other capacitors. And from here, it goes out through these two inductors, and actually these are current sensing inductors. They're sensing the current that's leaving the power supply. I'm pretty sure they are, because they're mounted on there, and they're, let me see if I can bend this up. Bend this up, we can have a look underneath. Okay, so of course they're split. Let me try and get one of these apart. I don't know. Oh yeah, here it goes. See, these are split inductors. Okay. Magnetic connection is made on the outside, but there's an air gap in between, and in the air gap they have a Hall effect sensor. I believe that's what it is. And a little amplifier, maybe a little op-amp amplifier, just to do the amplification before it picks up too much noise from the outside world. And I'm pretty sure they're using this to sense the output current on each of these channels, because there's 2 of these. One on this channel, one on this, and they're wrapped around what looks like, are these both? Yeah, I think One of these is positive, one's negative. I'm pretty sure this one would be negative, and the top one would be our positives, because the positive of the capacitor is connected. I think I can see it. It's connected inside, and here it's insulated. This side of the capacitor is connected to this plate. This side of the capacitor is connected to this plate. And these are 33 microfarad tantalums. Now, this transformer has 18 turns. This one has 26. I think this would be the 2.5 volt supply, and this would probably be the 3.3 volt. I could be wrong on that. Who knows? But I'm pretty sure this is transformer windings in here, and it provides probably isolation for the rest of the circuits. This is very nice build quality and design. Very quality components. Doesn't get any better than this. These are 2SK3313s MOSFETs. There's a bank of 8 of them, with 4 for each channel. It says designed in the USA, IBM S/390. It's a power product. So they probably use this in many different applications other than just this one alone. This seems like it might be something that they created for themselves. AC Bell Inc. It's got a date of 38th week of 08. It's got its own serial number. So yeah, and it looks like it's probably been in service for 10 years, and it looks like it's brand new. So it's probably over-designed for its application. You know, you don't see anything with regards to heat scorching or anything like that, or if you pull up a cheap Chinese power supply, you're going to see all the heat scorching going on, and you know, just from the lack of cooling and heat sinking that they go with. But this is interesting, little current sensor. Alright, I don't know what else to say about this. This is probably the last power supply piece I have. Next I have up is the processor itself. That's going to be a big one. I don't know if I'll be able to fit it on my bench. I think it's like 45 inches long, so I don't think it's going to fit here. I might have to think of something creative for the camera angles, but we'll get through it and get that one done. I have a lot of boards that I've scrapped already. They are input-output boards, and the disk array boards. I had a disk array, I think it was 10 drives, 8 arrays, and I think I scrapped all that already, so I can't really show you that. But we'll get on to the processor, and we'll have a look at that next, I think. So anyways, that's it for this one. Thanks for watching.